Hello everyone, welcome to In 5 Minutes. In this video, we are going to solve some sums based on discrete Fourier transform. The first sum is, the question tells, obtain the DFT of signal unit impulse that is represented as delta of n. So, the signal here is x of n is delta of n. Now, according to the definition of DFT, we are going to use this formula. But we know that the impulse function is defined as delta of n is equal to 1 and it is defined at only n is equal to 0. After that, when we put the x of n at n is equal to 0, that is delta 0, then the whole term, if we substitute here n is equal to 0, it becomes e raised to 0. So x of n is equal to 1. So this is a standard pair of DFT that when DFT is applied on impulse function that is delta of n, then the output is 1. We now solve another problem based on DFT. The question is, obtain the n-point DFT of the exponential sequence that is a raised to n u of n. So the x of n is equal to a raised to n u of n. U of n indicates that the sequence is from 0 to plus infinity. Now, substituting in the definition of the DFT, that is a general formula, we get x of k is equal to summation n is equal to 0 to n minus 1 a raised to n e raised to minus j 2 pi k n upon capital N. Taking this n that is here and the second point is here as common factor, we will get summation n is equal to 0 to n minus 1 a e raised to minus j 2 pi k upon n, the whole term raised to n. Now we have to use different formula for solving this problem, that is the finite geometric series sum formula. The formula states that summation of n is equal to 0 to n minus 1 c raised to n is equal to 1 minus c raised to n plus 1 upon 1 minus c. So, substituting this term as c in this formula, we finally get 1 minus bracket a e raised to minus j 2 pi k upon n, the whole raised to n minus 1 plus 1 upon 1 minus a e raised to minus j 2 pi k upon n. Now we know that e raised to minus j 2 pi k is equal to 1 minus j into 0, that is 1. So finally, we get x of k as 1 minus a raised to n, as here, when we substitute and expand this term, e raised to minus j 2 pi k into n upon n. N and n gets cancelled, so it remains with e raised to minus j 2 pi k. And in denominator, we get 1 minus a e raised to minus j 2 pi k upon capital N. So this is the final DFT which we obtain after applying this general formula. We solve one more sum based on discrete Fourier transform. The question is, find out the DFT of the sequence x of n 0, 1, 2, 1. We are going to use again the basic formula. This given signal is a 4-point signal. So let us compute the 4-point DFT. The 4-point DFT is given by x of k summation n is equal to 0, as it is a 4-point DFT, n is equal to 4. So it ranges from 0 to 4 minus 1, that is 3. X of n e raised to minus 2 pi k j upon 4. Finally we get summation n is equal to 0 to 3 x of n e raised to minus j pi k n upon 2. We will expand these terms. First, when n is equal to 0, x of 0 into e raised to 0 plus when n is equal to 1, x of 1 e raised to minus j pi k by 2 plus x of 2 e raised to minus j pi k when n is equal to 2. When n is equal to 3 plus x of 3 e raised to minus j 3 pi k upon 2. Now the x of 0, x of 1 and x of 2, x of 3 are the values of x of n. So we simplify the terms and finally we get 0 plus e raised to minus j pi k by 2 plus 2 into e raised to minus j pi k plus e raised to minus j 3 pi k by 2.